Hello, and welcome to chapter 4. Today we are talking about probability distribution. So we're using what we learned about probability and trying to display them like in a table, and then we can do different things to analyze those numbers. So first, I want to define a new vocabulary word. It's called a random variable. So not like random as in, oh, that's so random, like, no. A random variable is talking about like when you do a chance process, like rolling a die, flipping a coin, whatever. But then the outcomes themselves are numbers. So like rolling a die, when you roll the die, you get numbers like 1 through 6. So those are numerical outcomes. But then when you flip a coin, it's either heads or tails. So that would not be a numerical outcome. So other examples we could use are like, so it's a variable. So we usually say like x equals whatever, and we can use any letter really. But if we said x equals the number of sales calls a salesperson makes per day, so then all the different outcomes could be like the salesperson makes 1 phone call a day, 2 phone calls a day, 3, 4, 10, 20, and so on. Or another example of a random variable would be the hours spent on sales calls in one day. So now we're talking about like how many hours. So does he spend like 0.5 hours, 1.8 hours on sales calls, whatever. But notice how all of the outcomes are actual numbers. So that is the key thing. Another example, x equals the height of ninth graders, so like in inches or something. So 54 inches, 62 inches tall, whatever. So again, numbers. And those numbers could be either whole numbers or decimals, depending on the situation. So like the number of sales calls would have to be a whole number because I don't know how you would make like 3.5 sales calls. That would be weird. But then like the height of ninth graders could be something like 64.25 inches tall because we're, trying to be exact and we use more decimal places when we try to be exact. So depending on whether it's whole numbers or like decimals or fractions, there's different names for them. So the first one is the discrete random variable. Discrete means that there's like a countable number of outcomes, so usually whole numbers. So for example, when we talked about the X being the number of sales calls that a salesperson makes per day, those had to be whole numbers. So this would be considered as a discrete random variable. So specifically, like when we say discrete, it just has to have a countable number of outcomes. It can't be an infinite amount. So like when we talk about decimals, that's when we say there can be an infinite amount because you could have like all the decimals in between 5 and 6 or something like that. And so because there's so many different options, you could do like 5.5, 5.55, 5.5556. Like there's so many different options for decimals that that doesn't count as a countable amount. So that would be considered a continuous random variable. So discrete is whole numbers usually. Continuous is where you're allowed fractions, decimals, things like that. So in a continuous random variable, you have the infinite number of possible outcomes because of all the decimals and fractions. But the one thing is that like when we list out the outcomes, it might not necessarily mean that you actually have decimals or fractions. It's just that they're possible. So like for example, if we said x equals the hours spent on sales calls in one day, that person might have only made sales calls like on whole number increments. So like 2 hours, 3 hours, 4 hours, whatever. But because he can do like 4.5 hours of sales calls or something like that, because that's possible, it still counts as continuous. Okay, so now that we know what a random variable is, now we can move on to talk about probability distributions. So in a probability distribution, basically you're kind of just listing out all the different outcomes for your variable. So whatever your random variable is, say like how many hours you spent on the sales call or whatever, then you would list out all the different possible outcomes, and then right underneath that would be a row of all the probabilities of each of those outcomes. So specifically, when we make this in the form of a table, the probability distribution, if we use a table, can only be for discrete random variables because discrete means that like there's a countable, not an infinite amount of outcomes. So we can list them all out and then find the probabilities for each one. So with a continuous random variable, we can't use a table to show it, but there's other methods that we'll get to later. So when we do this table, the probabilities, there's a few rules. The basic one is that probabilities always have to be a number between 0 and 1. Could be 0, could be 1, but Mostly, we can't have negative numbers, you can't have numbers over 1, whatever. And then if you add up all the probabilities in your table, then all the probabilities have to add up to 1. So because all the outcomes that you've listed out represent the sample space, and if you remember, a sample space is the list of all possible outcomes, and the probability of the sample space happening has to be 1, because you're basically saying, like, with all the different outcomes, if this is all that could happen, then probabilities always add up to 1. So I want to do an example where we actually make a probability distribution. I've listed out the steps here, but it's a little bit easier to just do it with actual numbers. So first, we'll look at this example. We have an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Individuals were given a score from 1 to 5, where 1 was extremely passive and 5 was extremely aggressive. A score of 3 indicated neither trait. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. So here they're basically saying the random variable is the score on this test. So that score is a number, so that's why it counts as a random variable. So when we make our little table, we're going to start by labeling the top row as x. And then all the different outcomes of x for this test would be 1, 2, 3, 4, and 5. Okay, so then step 2 says find the sum of the frequencies, because for the second row, what we're trying to do is find the probability. So we would write this as like p parentheses x, like probability of x. So in order to find that probability, we're basically saying, like, to get a score of 1, the probability would be 24 out of the total, because that's how we normally find probabilities. So we would need to figure out the total of all our frequencies added together in order to divide that way. So adding all of these together, we end up with 150. So that means I'm going to be taking each of my frequencies and dividing by the total frequency in order to find each of my probabilities. So for an x value of 1, the frequency was 24 divided by the 150 would give us 0.16. I'm going to continue doing this for the rest of the scores. So for a score of 2, the frequency was 33 divided by 150, we get 0.22. For a score of 3, 42 divided by 150 is 0.28. 4, if we divide 30 by 150, we get 0.2. And for a score of 5, 21 divided by 150 is 0.14. Okay, so our last step is to check that each probability is between 0 and 1, and that the sum is 1. So when I look at all my probabilities, 0.16, that's between 0 and 1, 0.22 is between 0 and 1, 0.28, 0.2, 0.14 are all numbers between 0 and 1. Great. Next, we need to check that the sum is 1. So when I add 0.16 with 0.22 and 0.28 and 0.2 and 0.14, it should add up to 1. It does. So this table right here is the probability distribution of this random variable, where this random variable stood for the score on this passive-aggressive test. So lastly, they ask us to graph the distribution using a histogram. So we're back to graphs. When we make a histogram, remember to label your axes. So on the x-axis, it's going to be our score, x, because that was our random variable. On the y-axis, it's now going to be our probabilities. It's like the probability that we got of x. So we just found all those, so we know what numbers that we're going to graph. I'm just going to go by 0.10. Because I think my highest number is 0.28, so cool. So then when we make our bars then for a histogram, remember histogram, all the bars need to touch. So we're using our x values of 1, 2, 3, 4, and 5. And so for our first probability, it was 0.16 for a score of 1. So that's like about right here. For a score of 2 was 0.22, a little bit over 0.20. For 3 was 0.28, so almost at 0.30, 0.2, and 0.14. So like here. Close enough. Okay, so there's our distribution for the histogram. So if you look at it, remember we could tell the different shapes of a graph. So there was like skewed left, skewed right, symmetric, uniform. Those were the shapes that we wanted to look at. So here, remember uniform is where it's like pretty much the same height all the way across. Skewed left is where it's shorter on the left. Skewed right is where it's shorter on the right. So this would be symmetric because it's pretty much the same on the left and the right, kind of a mirror image of each other. So keep those shapes in mind because they do come back up. All right, so now that we know how to set up a probability distribution, we also want to be able to calculate the mean and the standard deviation for it. So remember, the mean is the average, the standard deviation is like how far away each data point is away from the mean on average. So we want to be able to calculate the mean first. It's basically like saying, if, like for this example about the passive aggressive test, if I had a bunch of people take this test, what would the average be? Knowing that the frequencies are spread out like this, knowing that the probabilities are going to be these numbers. Because if like 3 is more likely than scoring a 5, then when we calculate the mean, we also want to make sure that it's going to be related to the probabilities as well. So to calculate a mean, what you're going to do is first, the symbol for mean is like that mu Greek letter. It looks like an M, looks like a U, so we read it as mu. So we write it as mu of x, meaning like the mean of the x variable. You're going to add up the sum of all your x values multiplied by your probabilities, so P for probabilities. So if we were to do something like in this example here, this is actually the numbers from the last example that we did, just written out vertically instead of horizontally. So my x values are 1, 2, 3, 4, 5. The probabilities are the same ones I got before. So in order to calculate the mean, I'm going to take each of my x values and multiply it by the probability and do that for each one. So for an x value of 1, I get 1 times 0.16 is 0.16. 2 times 0.22 is 0.44. 3 times 0.28 is going to be 0.84. 4 times 0.20 is 0.80. And 5 times 0.14 is 0.70. Okay, so we just did all of the x's times the p's, and then lastly we have to add them all up because the sum. When I add all of this together, I end up with 2.94. So the mean is going to be 2.94, which means if I had a whole bunch of people take this passive aggressive test, the average score that people would get would be 2.94. So like most people are neutral, which is about right. Now that I've calculated the mean, now let's calculate the standard deviation. So the formula looks a little crazier. There's a big square root, and then we have this symbol, sigma, which is the sum of, we're going to take each of our x values, subtract the mean that we just got, and then square it. After we square it, then we're going to multiply by the probability. And then once you have done that for each of your x values, then you're going to add those all up. And then after you've added them all up, you take the square root of the whole thing. So doing this by hand takes a little bit longer, but it's doable. I'm pretty sure most people have the graphing calculator now, so I'm going to do it that way because even finding the mean, it's going to be faster. This process is actually something you've done before. If you remember back in chapter 2 when we did the mean and standard deviation of a frequency distribution, it's the same process. We just didn't have probabilities. You had frequencies here instead. But it's pretty much the same buttons. So first, have your calculator out. You're going to type in your lists. So remember, our favorite button is stat. We want to edit. So hit enter. And then in your list, in L1, you're going to type in all your X values. So for us, that was the 1, 2, 3, 4, 5. Okay. In L2, you're going to type in all your probabilities. And remember, they have to be in the same order as your X values. So the first one was 0.16. The second one was 0.22, 0.28, 0.2, and 0.14. Okay, so to calculate the mean, you know how we multiplied our X values with our probabilities? Well, if our X values are in L1 and our probabilities are in L2, then when I highlight L3, I can just type in L1 times L2, and that'll take my X's times my P's for me. When I do that, I get all the numbers that I got from like multiplying. And then we wanted to add this up really quickly by using that sum feature in our calculator. So if I quit, so second mode to quit, and this is like back to our home screen where we do our calculations. Second stat, go over to math. Number 5 is sum. So if we sum L3, remember L3 is the second and then the 3 button and my parentheses. That'll give me the mean that I just got. Okay, so that was doing the mean in the calculator. So doing the standard deviation then, I'm going to go back to my list. This time we're basically trying to type in our standard deviation formula into L3. If you want to do it in L4, that's fine too. So we're going to scroll up to the top. I'm going to clear it first and hit enter so that I don't have any more numbers in there. So we want to start with the parentheses. We're going to take our X values and minus the mean from it. So our X values were in L1. Minus, our mean was 2.94. And the parentheses, we want to square it. So I'm just following the formula over here. I just squared it, and then I'm going to multiply it by P. And all of our probabilities were in L2. So it'll be times L2. So this is the formula that you want to type in. Remember, you want to make sure that you're highlighted on L3, then type this in. When you hit enter, it'll do all those calculations for you. Okay, once we have that, our formula said to add them all up and then square root the whole thing. So to add them all up, I want to do the sum of L3 again. So I'm going to quit second mode, go into sum again. So second stat, over to math, number 5. Enter. Sum of L3, I get some number, cool. But then finally, we want to take the square root of the whole thing. So square root, and remember you can scroll up to copy paste your answer. So when you highlight it and hit enter, it'll copy paste it for you. Enter. So that's going to be our standard deviation, 1.27, depending on how many places, decimal places the instructions say to round to. We'll just go with 2 decimal places here, so 1.27. If you were doing this by hand, not recommended, but if you must, then what you're doing is basically for each X value, you would take 1 minus your mean of 2.94, square it, and then multiply by the probability of 0.16. Do that for all of them. So our next X value was 2 minus the 2.94 times its probability, which was 0.22. Keep going, add up everything you get, and then square root whatever you got from adding everything. Kind of a longer process, more tedious because you have more things to type in rather than having your calculator doing everything at once for you. But it's doable. So our answers for the mean was 2.94. Standard deviation was 1.27. I'm going to do one more example that's slightly less straightforward here, because here when we calculated the mean and the standard deviation, they gave us the table already. So in this next example, they're not going to give us this table. We have to make our own. So in this example, at a raffle, 1,500 tickets are sold at $2 each for the 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. What is the expected value of your gain? So first, I want to talk about this word expected value. Expected value is like, on average, what would you expect to gain here? So really, they're asking about a mean. So anytime you see the word expected, they're basically asking you for the mean. So here we just need to calculate the mean, but we need to make that table first for the probability distribution so that we know what numbers to multiply together and stuff. So they're talking about the gain here. Because if we're playing this game, we're paying $2 to play, but then we could win these different like prize amounts. So if I paid $2, but then let's say I won the $500, how much did you actually gain? Because you paid $2 already. So if you win the 500 back, then you're really only winning $498 because you already spent $2. So when I make the probability distribution here then, if my X variable stands for like what I gained, then by winning the $500 prize, I'm only gaining $498. Let's say I won the $250 prize. I would have only gained $248 because again, I had to pay the $2 to play. The $150 then would be a gain of $148. The $75 would only be a gain of $73. The last outcome that's possible is if I didn't win at all. Very sad, I know. If you don't win at all, you've basically lost $2. So we're going to write that as -2 because you didn't win anything. It's not a positive amount if you lose money. Okay, then we need to calculate the probabilities for each of these outcomes. All right, so for our probabilities, it says there's 1,500 tickets that are sold. So like the total amount of tickets is 1,500. There's 4 prizes, meaning there's 1 ticket where you win $500, there's 1 ticket where you win $250, 1 ticket for $150, and 1 ticket for $75. So if 4 of the tickets are winning tickets, how many tickets are not winning tickets? So to find those probabilities, we know there's 1 ticket where I could gain $498 by winning the $500 prize. There's 1 ticket to win the $250 prize, and that's where I would gain $248. 1 ticket to win the $150 prize, 1 ticket to win the $75 prize. Okay, so 4 tickets out of the 1,500 are winning. That means the rest of the tickets are going to be losing tickets. So 1,500 minus 4 is 1,496. So the probability of losing and not winning anything is 1,496 out of 1,500. So that would be the probability of gaining -$2, of losing your $2. Okay, so now I have it set up. Remember, we have to check all of our probabilities are supposed to be between 0 and 1, which they are. If you added all of these up, you should get a sum of 1. If I add up 1 over 1,500 plus 1 over 1,500 plus 1 over 1,500 plus 1 over 1,500 plus 1,496, I would get 1,500 over 1,500, which equals 1. So that's good. Okay, so from here, we can calculate our mean. So I'm going to do this in the calculator. You can do it by hand if you want. So in my list, stat, edit, let me clear everything first. Remember, clear is to highlight the L1 or L2 or whatever, hit clear, and then enter. Don't hit delete because that'll just get rid of the entire list. Okay, so our X values go into L1, so 498, 248, 148, 73, and -2. When you type in the -2, make sure you're using the negative button here, not the minus sign. There's a difference. Okay, and then our probabilities, I can actually type it in just as a fraction, 1 over 1,500. Your calculator will convert it into a decimal, And here, if you ever see the E, this is scientific notation. So your calculator, just let it do its thing. So 1 over 1500 again. And the last one was 1496 out of 1500. Okay, so from there, we want to multiply all of our x values with our probability. So scroll all the way up to L3. We're going to do L1 times L2. And then we want to add all these numbers up. That's in L3. So I'm going to quit. And then sum is second stat. Number 5, sum of L3. Negative 1.35 is going to be our mean then. Okay, so we're saying on average, we're going to gain, because that's what our x variable stood for, we're going to gain negative 1.35, which really means you're losing money. If you played this game a bunch of times, you're gonna lose $1.35, which, meh. But this is how casinos work too. Your chances of winning are small, but your chances of losing are much greater. So then, for any casino game that you play, same probability distribution, not like the same probability distribution, but you know, it's similar in that like winning money is going to be a small probability, losing money is going to be a big probability, and then on average, you know the phrase because the house always wins, it's because on average the house gains like it's a small number, not like $1.35, more like roulette, I think the house wins like 5 cents on average. But then because there's so many people that actually go to a casino and play these games, the house will actually gain a bunch more because those 5 cents multiplied by all the different games that people play is going to be a lot. So that's how these averages work. Thanks for watching. Bye.